Okay, we're going to talk about using the sum and difference formula when it comes to trigonometry. So here's our sum and distance formulas. You will see that they kind of have a pattern to them. You'll have to memorize them when you do these, but really it's just with the pattern. Um, with this sign, the thing that I notice when I do sine is that if it started with a plus, it is a plus. When it's a subtraction, there's a subtraction. And for the sine, it's sine of the first one, and then cosine of the second one, and then it's cosine of the first one, sine of the second one. So they flip flop. Where if we look at cosine, first thing I notice is if it starts at plus, it ends up a subtraction between. If it starts as subtraction, it ends up as addition. And then you notice it's just cosines of x and y, and then it's sine of x and y. So it just flips both of them. Um, but yeah, as you do these, you kind of get the repetition of the practice with them. So let's go ahead and take a look. Okay, so it wants us to evaluate. So on to an answer. So originally we talked that you can just put cosine of 75 degrees in your calculator to get an answer, but you can technically kind of break those up sometimes and use it without a calculator using these sums and distance difference formulas. So I'm going to use the fact that 75 equals 30 plus 45. So I rewrote that as cosine of 30 degrees plus 45 degrees. So now that kind of looks like one of those formulas that we just saw on the last slide. It's a cosine of two angles being added. So it would be cosine of x plus y, which is cosine of x times cosine of y minus sine of x sine of y. Okay. The reason why I picked 30 and 45 is because those are actually angles that are on my unit circle, so I can actually get those exact values pretty easy, and I don't need to use a calculator to get a decimal. Okay, so that's why we broke it up into those two numbers, because those are easier to work with, because we can use our unit circle to actually get those exact values. Okay. So now I'm going to go ahead and plug in into that formula that I have. So I'm going to go ahead and have cosine of 30 degrees times cosine of 45 degrees minus sine of 30 degrees sine of 45 degrees. Okay. Now you can use the unit circle, or if you need to kind of draw one off to the side, okay, 30 degrees would be right there, okay, which would be the point. My x value would be square root of 3 over 2, and my y value would be 1/2. Okay, and then 45 we know is square root of 2 over 2 for both the x and the y value. Okay, so let's go ahead and plug those values in. So cosine of 30 degrees, well, cosine is the x value, so this is going to be cosine. Oh, not cosine. It's just going to be square root of 3 over 2 times cosine of 45 degrees is square root of 2 over 2 minus sine of 30 degrees. Well, sine is 1/2. Okay, and then sine of 45 degrees is the square root of 2 over 2. Okay, now we can kind of clean this up. So square root of 3 times square root of 2 is square root of 6 over 4 minus square root of 2 over 4. They have this common denominator, so I can go ahead and say that this is going to be square root of 6 minus square root of 2 over 4. Now that's the exact value. Now if I wanted to plug that into the calculator and then also plug in cosine of 75 degrees into the calculator, I should get a decimal answer that matches. So if I look at this next one, I see sine of 5 pi over 12. Well, I notice that I can rewrite that as 2 pi over 3 minus pi over 4. So I'm going to go ahead and do that. I'm going to rewrite this as sine of 2 pi over 3 minus pi over 4. Okay. Then if I look at my formulas, so the formula is sine of x minus y would be sine of x times cosine of y minus cosine of x sine of y. That's on the slide before. So now let's go ahead and plug in what we have. We have sine of that x, or that first term, which is 2 pi over 3, times cosine, the second term, which is pi over 4, okay, minus cosine of the first term, which is 2 pi over 3, times sine of the second term, which was pi over 4. Okay. Now, if you need to, again, you can kind of look at that unit circle, or we can think about the unit circle. Well, 2 pi over 3 would look like that, okay, which tells us that our x value would be 1/2, and our negative 1/2, and our y value would be square root of 3 over 2. Okay, and we talked about pi over 4 is just square root of 2 over 2 for both. Okay, so now we can go ahead and substitute what we know there. So sine of 2 pi over 3 is just square root of 3 over 2, times cosine of pi over 4 is just square root of 2 over 2. This is just a multiplication sign. Okay, minus cosine of 2 pi over 3 is negative 1/2, times sine of pi over 4 was square root of 2 over 2. Okay, so we can clean that up a little bit and have the square root of 6 over 4, and this is going to be minus negative square root of 2 over 4, which just becomes a plus, so it would be square root of 6 plus the square root of 2 all over 4. Okay. Same thing, you could check your answer by plugging both of those into the calculator and notice that they are the same. Another thing that we can do is we can simplify them, trying to make them in smallest terms possible. So if we look at this first one, and we look at those basic formulas on that first slide, I notice that it kind of resembles the tangent one. The tangent one, it matches the one that goes tangent of x minus y, or an angle minus another angle. I notice that because the big thing that's the takeaway is tangent of 37 degrees minus tangent of 13 degrees. Since that's subtraction, it will be subtraction there. So what I can go ahead and rewrite this as is just tangent of our first angle, so 37 degrees minus 13 degrees. Okay. So then that would be tangent of 24 degrees. And it just wants to simplify, so that's our answer. Now if we look at this second one, okay, the first thing that I notice is that it's sine, cosine, and then it's cosine, sine. That gives us kind of the dead giveaway, since they flip like that, is it's going to be a sine. Okay, and we talked about how the sine stays the same. So this is going to be sine of the first one plus the second one. Okay, so this is going to be sine of 8x plus x minus 1. And we can combine like terms, so it's really just going to be sine of 9x minus 1. Okay, and that's it. Okay, that'll help us to what we're going to do next, because we can kind of manipulate these to make them look like what we want them to look like, which comes into play when we want to verify each identity. So if you remember before we left for break, we talked about verifying. We want to work with one side so it matches the other. Okay, so if I look at this first one, I see that I have sine of 3 pi minus x. You can split that up in using the formula. So we have sine of the first one, which is 3 pi, and then it would be cosine of the second one, which is just x, minus, because for sine it stays the same, so minus, and then it's going to be cosine of the first, so 3 pi, and then sine of the second, which is x. Okay. Now I can go ahead and use what we know about and kind of simplifying some of these, because I know that sine of 3 pi, if we think about it, sine of 3 pi, if we think about our unit circle, 3 pi is right here. Okay, so sine would be our x, y value, which is 0. So this is really 0 times cosine of x minus, well, cosine of 3 pi, our x value would be negative 1. So this would be negative 1 times sine of x. Okay, and this still equals sine of x. You can just bring this down. Okay, so now we can say, okay, let's simplify this. Well, 0 times the cosine of x is 0. Negative times a negative is a positive sine of x. So we can really, 0 plus sine of x is just sine of x and that equals sine of x, so we know that it works out. Okay? So we kind of go ahead and expanded it, simplified, since we know that we know what sine of 3 pi is and cosine of 3 pi is, and then we kind of worked it out and simplified till it matched the right side. Okay, let's look at this next one. Okay. I'm going to go ahead and kind of do the same thing. I notice that I have two things that are either adding and subtracting angles so that I can split them up using those formulas. So I'm going to go ahead and rewrite this one as the cosine formula, which would be cosine of the first, cosine of the second, and then that sign switches to a plus, sine of the first, sine of the second. Okay, and I'm going to do the same thing with that sine. I'm going to rewrite that one as well. Okay, I went ahead and rewrote that using that formula. I also on the left-hand side kind of jotted down a unit circle to help us where pi and pi over 2 are on that unit circle and what those points are. So cosine of pi, the cosines are x, so that would be -1 times cosine of theta plus sine of pi is 0 times sine of theta plus sine of pi over 2, well, sine is the y value, so that would be 1 times cosine of theta. And then cosine of pi over 2 is 0, so this would be 0 times sine of pi. Okay. So if we kind of combine like terms, we're going to have negative cosine of theta plus cosine of theta. 0 times sine of theta is 0, plus 0 times sine of theta is 0, so these kind of just vanish since they're 0. And then we know that negative cosine of theta plus cosine of theta would just be 0, which is what we wanted the right side to equal. Okay? So we can kind of use those formulas to also help us verify.